later. So if you have any questions, just feel free to ask them there. And our final session before the break is a crash course in building research skills and statistics given by Dr. Anna Podlasek, who's a biostatistician and research fellow in Nottingham. Thanks very much.
Hi there, can you hear me?
Yep.
Perfect. So technical problems are after us. That's the most important point. So hi, I literally didn't know what to tell you. There's so many stuff that we can tell about building research skills and as well as the data analysis. But I hope you just to direct you today into the correct directions. And if you have any further follow-up question, there is my email and Twitter handle, and I'm more than happy to answer any follow-up questions. So I will start with the disclaimer. Primarily, I'm a doctor. I studied the majority of my life medicine, and this is my primary focus. But I also did masters in biostatistics. I was very lucky in at my university where I studied in Poland. We had the first translational medicine institute in Poland, where we were making this link between the basic science, understanding genetic backgrounds, and working with the big data into how it impacts the everyday clinical work and future patient outcomes. Also, as a second thing to a little be aware of, I will be recommending a couple of softwares, and I'm a Windows-based person, so I might miss a couple of Mac-based or Linux-based solutions. So this from front apologies. So if you're tired, if you don't want to listen to this quite technical lecture, the only advice that I really want you to remember from the next 15-22 minutes is to do good clinical practice course. The QR code will lead you to the NIHR website where this course is a complimentary one, and you can just do it for free. It will introduce you to all the regulation on the international level that are guiding the whole clinical research. It will show you what you need to abide for, how the trial master file look like, and how to gain consent, informed consent from patient. And whenever you're going to the cooperation in the big trials, in the smaller trials with the companies, always they will ask you about your good clinical practice. It will need to be refreshed on the yearly basis, but I think it is a very good start to come into a little bit more scientific world and understand what's A and B there. And then when we think broadly about the research cycle, in general, I would say think and plan. I would a little bit exchange it into the be interested and explore, just be curious and see what is the conversation of other smart people around about it. And then the more you read and the more you understand the problem, you can start discovering questions, the one that are not yet answered, and building up how I can answer this question. And that would translate into your research project. Then things are simple. You just gather and analyze the data, you sum up in the publication, and then after this successful publication, you also disseminate those results a little bit more, not onto only scientific world, but also into the more lay audience. So in this first stage, when you just want to, in general, touch the topic, there are a couple of resources that I can recommend. First of all, there are different databases that you can use to find medical articles. Usually, the first good step is to go to the library. There are always awesome people over there and very helpful to guide you in any deeper research or just going through the resources. The databases that are most used in the medical world is PubMed or Medline, Scopus, Cochrane, and Embase. There are some more specialized types. So for example, if you're interested in rehabilitation, there is Pedro. If you're interested more in psychology, there's PsycInfo. And there's a lot of engineering, which is very important for interventional radiology and robotics in that also can give you additional information. Then when you're doing your exploration, it is good to know yourself. because you will never remember everything. And it is good to have a little bit of structure and know how you put your thoughts into the order that you can come back to them. And it is good also to become a friend with one referencing manager. It makes your life much, much simpler. I personally use Mendeley. I love it for my keyboard shortcuts. I'm so used to it. I've been using it for at least 10 years. So this is my choice. But EndNote is very popular amongst the especially universities. Zotar and Sybase are the other alternatives. I think that Word and Google Docs also, they have their own just options to do the referencing if you really want to avoid them. And then also when you are reading studies, you have to have always in the background of your mind whether this study, is it okay? Is it a good quality study that gives me information that I can trust? And then again, we've got multiple ways to assess the quality or risk of bias included in the studies. Robbins and Ruptu, they're the British one, and they are very well described online. They have a very nice visualization tool called RobVis, and they are coming as a package. Robbins is for observational studies and Ruptu is for randomized clinical trials. Then you can also use GRADE or CASP or whichever is used in the team that you are working with. This is also very crucial to get to know your people, because research is very hard when you are on your own and you always need to have your folks around you. And it's good for you to work within the same space when it comes to the software or to the methods that you are using. So after that, after this whole reading that can take much more longer than you can expect, you can discover your question. So it is just this small bit of knowledge that is missing in what was reported or is not well proven. And then you can just find couple of ways how to best answer the question that you just posed. And I think that crucial in this level, there are also mentoring sessions and a lot of discussions. This could be either in half an hour or in 20 minutes during our breakout room then, but also you can reach out to the professors at your university, the other doctors at your hospital, or sometimes in European or international collaboration. So for example, European Stroke Organization had a regular yearly 3-day course about research and how to develop young researchers into the stroke research. So just go and look into your sphere of interest, whether is there nationally, internationally, anything that can guide you further. And then when you have it, you will have to organize your research depending on the type. You will have to be aware of ethics application, which is required for any human participant studies, and also the grant writing to get funding for your research. I personally did a couple of courses on grant writing at my university, and they were really useful because they are giving you perspective of what is needed for your idea to be successful, to be funded. And then when you have everything secure, so we've got idea, we've got funds, we've got all the agreements, and we can start doing research itself. It's hard to tell what is the best way to gather the data. You can go online and find some databases, open source, that you can just use. It is especially easy with imaging because there are multiple CT heads or any other images, just X-rays, CT pulmonary, that you can just download. It takes a couple of gigabytes, but they are accessible. And then make your statistical analysis of that. Or maybe you will have to do the data gathering from the scratch, from your patients that you meet. It all depends on how you want to answer your question. And this is a little bit of disillusionment that I had when I started the biostatistics. It's not all about this fancy statistical models, about those advanced algorithms that explain you all the relationships. It is more about having a good quality data. And a lot of people, so for example, Mark, who's data engineer at Slack, he's calling himself data janitor because he's just going around and cleaning the data, and this takes 80% of his time. So to make our life easier with this this basic ground as our data set that we will be working with. There are just a couple of my practical tips that could be implemented. So first of all, I would suggest to use consistent capitalization and spaces. So trust me, so for example, male with capital letter and male with small letter starting is completely different for the statistical software. So it is good to be consistent. To make life easier, it is better to encode data with numbers and just have a legend that explains what is what. Then how to even look at this is that one row is one participant, one column is one variable. And this will be valid across all the majority of the statistical software as a structure. The next things that I think is quite, maybe it's non-obvious, but keep the variable names, so column names, very short. Very often you will have to later on input it into the softwares or just use it somewhere. And it's better to have this kept short with the longer label that has a full explanatory how this works. And especially when you're gathering your original data from the patient, there are always some little things that you want to remember about this patient, that there's some adverse impact that was not predicted, or their attitude toward the study that they can, for example, be lost for follow-up. So it's good to have the separate column for comments and just leave it out of the main data set. And most importantly, just keep it simple. Try to have short terms, short answers, and very in logical order. So this is just the description of the data set, which should be always done whenever you're working with. So you need to know how many cases you have, how many variables. And then it's good to do this master index when you're writing variable number, then the short variable name, you're defining the type, whether it's characteristic, numerical, you're saying length or defining the coding. And then in the labeling, you're explaining what is what, because then you can always share your data set and anyone who will enter it can validate what you did. And you also remember what was what. And it's easier for collaboration and highlights the idea of the open science. So in general, we have variables, which can be numeric and categorical. Numeric can be continuous. So for example, your CRP values or your hippocampal volume. And then there could be a discrete. So for example, we've got only 2 cerebral hemispheres. We cannot have 1.5 or 4 or 3 1/3. It's usually when we are counting things or people. Only if we are testing diagnostic test accuracy test, we can only count full people with the disease. We cannot have half person with, for example, abdominal aneurysm. And then the other type of the variable is the categorical one. And then it could be either nominal. So it could be, for example, gender, male and female. And the other type is ordinal. So it is more about the scale. So for example, how much do you agree with the previous statement? And then you have numbers from 1 to 5 with the growing importance. And then when we have our data set, when we know what we have and we can define our variables, we can start with our statistics, which is a little bit of like building the house. So we will start with descriptive statistics. For continuous data, it will be mean, standard deviation, median, interquartile range. And then we also need to know how they behave. So we need to know the distribution of the data, whether is it normal or non-normal distribution, and its variance. And then we can start choosing our tests. So simple correlation, which was just giving whether is the data associated with the other thing or not. And here I will just leave the name Pearson-Spearman, depending whether is it parametric or non-parametric data. Then you can start comparing groups. So again, for different types, there are different tests to be used. And further on in the learning, it will be good to get into the regression modeling, which will be the first one that can give you a little bit of cause-effect relationship. And there are multiple more advanced statistical models. So when we know the type of data, it is just a simple algorithm which statistical test to use. I won't dwell into the details, having in mind that there's not much time and you are, I'm sure, tired of listening after the whole day today. So the good thing is that we have multiple choices, and there's a lot of statistical software that can make your life much, much easier. So Excel is surprisingly very powerful program. And I love this blogspot that can give you a really advanced regression models, how to do in simple Excel. Then there are more click and point programs like Jamovi, Statisticas, PSS. They differ between licenses, whether they are for free or do you need to pay for them. But they are simpler in the way that you don't need to really do a lot of programming. Stata is a little bit between R and the others. So Stata requires a small level of programming input and variables, and R is purely programming. But R is, I think, this is open source software and one of the most powerful. And then, depending on your methodology and your question, you can use Review Manager, which is by Cochrane collaboration, or JASP for meta-analysis. RapidMiner is for deep learning methods, and Power BI is for visualization. And also, you can forget all about that I said in the last minute about the statistical software, and just go to this website, which was developed 20 years ago by Ops and Gynae department in the University of Hong Kong. And you can do all your calculation online. As an example, I put, this is meta-analysis of the diagnostic accuracy test. So it's even generate the graphs for you. It's a really good website if you just want a simple tool to deal with. And there are also multiple ways to learn the statistical theory. Again, it depends whether you're a computer person, whether you're a book person. It's good to go for courses to get practical exposure, not only to read the theory, and just find the one that is the easiest for you to understand. There's also YouTube. It's also a very good resource. And then we go to the write and publish phase of our research cycle. It's hard. Writing in medicine, in health, in scientific health is quite a big skill to get one. There are nature masterclass that can make your life a little bit easier. And from what I want you to get from this slide is Equator Network, which is summary of all the important guidelines that are needed for reporting the scientific studies. So just in your own time, go through the flowchart, and then by knowing by which guidelines you need to abide, you need to know what to include in the study, and you make sure that is always there. And also another important question is how to choose the journal, because you want your topic to be disseminated to the appropriate audience. So what I would look like is impact factor. Is it, well, a good journal, well respected? Which databases is it listed in? Also the individual journal's aims and scope, and also review instructions for authors, whether you have limits of figures, tables, how many words you can write. And this is very good to also consult with your collaborators. They also have their favorites, where to publish, which has the shorter publication or longer publication time. They will be more than happy to advise on that. And as the last stage, it is to share your work and be happy about it. So the ResearchGate is, some call it a little bit of scientific Facebook, where people store their full PDFs and you can share your scientific work. ORCID ID is like every article has DOI, so digital object identifier. So ORCID ID is this digital object identifier for researchers. It links to your CV, to your publications, and it makes your life much easier to submit articles, because it is well known to be able to log into the manuscripts management centrals. Then there's also Publons, which has a good strength of also verifying your peer review. So if you are invited to assess others' article, it is also acknowledge your work into the scientific work. And then obviously you've got all the other social media of the world, which you classically use. And conferences. It's always good to talk about your research, to get the feedback, what people think, what can be done. So I think that will be the end of my ramble. I know that's all sounds quite complicated. There's a lot of this, but whenever I have my imposter syndrome, I look at this citation by Albert, and it is just exploration process. Thank you for your attention. If you have any questions, that's straightforward.
So any questions, just feel free to type them in the chat. In the meantime, thanks, Anna. I thought it was a really well-rounded talk with lots of really helpful tips and recommendations for resources.
I echo what Rosemary said. Hi, Anna. Thanks so much for your talk. And you obviously had quite a hard task for, and even a full-time statistician to be giving all you need to know in statistics in a less than half an hour session. I think you did a fantastic job and highlighted what are the key areas to at least think about when you're approaching a project. Just wanted to ask, for you, what package do you normally use or find the most practical for the sort of tasks that you're doing day to day with your research activity? Which package?
Which software? So
yeah, it
depends on the statistical methods. So for example, I learned statistics in Statistica. This was the program that we used in Poland. So all the simple descriptive statistics, this is my go-to package. Then if I'm doing meta-analysis, it's usually Review Manager.
Yeah.
If I want to do the fancy, nice tables, it is Power BI. If I want to do the regression, I tried a couple of softwares for regression models. And Stata is currently on my best because it gives the best comparison between models. So again, sorry, my apologies, there's no simple answers. It depends on what is the question in the research itself.
I think a lot of centers now, there's a bit of R training integrated into their sort of research training. And I know places like RSNA and conferences do offer these sort of short courses if you go to the conference. So RSNA is the big radiology conference every year. It's held in Chicago, and they get over 50,000 people attend, and they have R sorts of different levels for people starting out learning R, and those are sometimes quite useful. But there's also, as you alluded to, lots of online resources, videos and free packages you can use. So thanks for pointing out all those useful resources. And
just one thought, so one more. Each statistical software have their own instructions, so it's good to follow. And in terms of R, on Coursera, there is a great R statistics in public health from University of London. It is four chapter course mainly about basics and regression, and goes through all the bases if you're interested. And also, I know that there's a question from Divya. As a medical student, how can I choose which clinical cases are good enough for writing up a case report for conferences publications? First of all, the one that caught your attention. So the one that surprised you, the one that you didn't expect how they will develop, or the one that are most discussed in the department.
Okay, if there are no more questions, we'll take a quick break now, and then we can